So in this video, we're going to do some practice problems for writing balanced equations, skeleton equations, and word equations. We're going to focus on balanced ones. You should know how to go from a word to a skeleton to a balanced and vice versa. And the more practice you do, the easier it'll become. So here we have a word equation provided, and we're going to write a balanced equation for it as the question's asking here. I always start off by writing a skeleton equation first. Now, in this case, the states are a bit tough to figure out, so we're not going to worry too much about states yet. Typically, you'd have some descriptions, some idea as to what your state should be based on what the description is. But right now, we're just given a word equation. And there are ways to figure out states, and we'll do that in a future lesson. So potassium sulfate is K2SO4, and I know that by doing the crisscross method. And then we have sodium hydroxide. And again, I'm doing the crisscross method there to figure that out using my metal and polyatomic ion. And generally, these two would be aqueous. I would know the NaOH is aqueous because for bases we said they would be aqueous, but they could be solid sometimes. So I'd have to give you a bit more information. Then we have potassium hydroxide over here. That was determined using a crisscross method. And then sodium sulfate, also determined using crisscross method. And so what we're going to do is we're going to try to balance this now. We can treat the polyatomic ions as being individual units. And so I'm going to start by balancing the potassium. I just need 2 on this side. Now that I have 2 potassiums, I have 2 potassiums there and 2 hydroxides. So I'll put a 2 over here. That'll give me 2 sodiums, 2 hydroxides. I have 1 sulfate, 2 potassiums, just like on the other side, and 2 sodiums, like on the other side. And so this is a balanced equation. Just to indicate that I'm done, I'll put a coefficient of 1 there and 1 here to show I'm done. So that was just an example of going from a balance to from a word to a skeleton, and then to finally a balanced reaction. Let's go ahead and try this one out over here. So we have iron 3 nitrate plus ammonium hydroxide produce iron 3 hydroxide plus ammonium nitrate. And so it's the same idea. Make the formula using your crisscross method. So we have iron 3 nitrate, so FeNO3 3 plus ammonium hydroxide. So doing the crisscross, we get NO4OH. And then that's going to produce some iron 2 hydroxide, so FeOH2 plus ammonium nitrate, which is NH4OH. And so, just by the way, you would probably already noticed these type of reactions, what they are, that they're both double displacement reactions from grade 10 and review material. So let's see, let's go ahead and balance this. So I'm going to treat these, oops, I forgot, that's not hydroxide, that's nitrate, right? So that's ammonium nitrate. So I'm going to treat nitrates and hydroxides like individual units. So for nitrates on the left side, I have 3, and I only have 1 on the right side. So I want to make 3 there, so I'll put 3. They'll give me 3 nitrates and also 3 ammoniums. And for hydroxide, okay, this is going to be a bit weird here. If I put 3, it won't work out because I'm going to have, if I put 3 in the front to get 3 ammoniums, I'll get 3 hydroxides and 2 there, and 2 on the right side. So I think I need 6 total. 3 times 2 is 6. So there's a common factor there. So I'll put a 3 over here. That'll give me 6 hydroxides and 3 irons. And then what I'll do is I'll put a 6 here. And that will give me 6 ammoniums and 6 hydroxides. Now I need 3 irons. So I'll go ahead and put 3 over here. That'll give me 3 and then 9 nitrates. 9 nitrates. So I need 9 nitrates. And so what I can do is, let's see. So I have 3 irons there. 3 times 3 is 9 nitrates. 6 ammoniums there. 6 hydroxides. So yep, that works out. 6, 6. Need 9 nitrates. So let's go ahead and figure that out. So if I put a 9 over here. Oh, yeah, that's why I'm having a problem here. So notice I was having some troubles balancing this. And for some reason, it just wasn't working out. And I found my mistake. And sometimes that happens. This is iron 3 hydroxide. So you're probably watching the video and thinking, Mr. Efrati, iron 3 hydroxide, not iron 2 hydroxide. So let's put a 3 there. There you go. Now let's restart that. So I found a mistake. and it should be a little bit easier. And sometimes mistakes happen. If you see you just can't balance, go back and refresh and take a look at what your equation was and just see if you made any errors anywhere. So now I think I'm good. Now I can try this out. So I can put 3 nitrates there. That gives me 3 ammoniums, 3 nitrates, and 3 nitrates on that side. That's good. I'll put 3 there, so it gives me 3 ammoniums, 3 hydroxides, and everything else is good. The 3 hydroxides here, 1 there, so I'm fully balanced now. There you go. Sometimes mistakes happen, and you just go back and check to see what the mistake was. So again, my mistake is I thought it was a 2 there, and I put 2 by accident. So next, let's go and try question number 3. SF4 plus H2O produce SO2 and HF. So here we already have an equation written out with all the states for us. Great. We just need to figure out what the how to balance this. And so it looks like we need to balance our O's and our F's. So if I were to balance the and also the H's. So if I want to balance, I'll start off by balancing the F's. So 1S, 4 F's there. 1S, 2 O's, 2 H's, 1 O, and then 1 F here, and 1 H. So I'm going to get 4 F's. So I'm going to put a 4 here, and that'll give me 4 H's and 4 F's. So the F's are balanced. And I'm going to try to get 4 H's on the other side as well. So I'll put a 2 over here, and that'll give me 4 H's, and that'll give me 2 O's. So now I think I'm balanced. I have 1 sulfur on both sides, 4 H's on both sides, 2 oxygens on both sides, and then 4 F's on both sides. So I'm just going to finish off by putting 1 and a 1, and now I have a balanced equation. So let's go ahead and try this next one out over here. So that's supposed to represent an arrow. We have calcium hydroxide plus H3PO4 gives us calcium phosphate plus water. And we want to figure out how to balance this. I usually like to write out my water as HOH, so I'm just going to be doing that here. And let's see if I can figure this out. So I'm going to treat my hydroxides as individual units and my PO4s as individual units there. So I'm going to try to get 2 PO4s on this side. So if I do that, I get 2 PO4s, and that gives me 6 H's here and 2 PO4s. Okay, so that works. And so my PO4s are balanced, but my H's aren't, neither my hydroxides. So I'm going to try to get 6 H's now. So I'll do 6 over here, and that gives me 6 H's, but also 6 hydroxides. And what I want to do is try to get 6 hydroxides on the left side. So if I put a 3 here, that'll give me 3 calciums and 6 hydroxides. And notice that balances out the calciums there, and my phosphates are already balanced as well. So I think like this, 3, 2, 1, and 6, everything is balanced. We have 3 calciums on this side, 3 calciums on this side, 6 hydroxides on that side, 6 hydroxides on this side, 6 hydrogens, 6 hydrogens, 2 phosphates, 2 phosphates. And so our equation is balanced at 3, 2, 1, 6, and it has to be reduced. So if you had 6, 4, 2, 12, you'd have to reduce it to 3, 2, 1, 6. All right, so let's go ahead and try out the next few examples. So notice that there's states given here, but states are normally not given in a word equation. They're just there to help you practice with writing states out. So in an equation like this, you could definitely write the states. So let's start off by writing a skeleton equation with the states there. So potassium chlorate using our crisscross method is KClO3. We're told it's a solid, so we can put a little S there. And we can put our arrow over here, and it's going to give us potassium chloride, and we're told that's a solid as well. Plus some oxygen. So oxygen, don't forget, is one of those Hofbrinkels, and it's going to be in its gas state. So even though we're not told gas state over here, you should know based on the fact that it's oxygen that it's found in its gas state. It's red on the periodic table as well. It's one of the Hofbrinkels. So we have that. Now we can simply balance it. Let's put a 2 over here to get 2 potassiums, 2 chlorines, 6 oxygens. Let's put a 3 here, that's 6 oxygens, a 2 here, that's 2, 2. So now we're totally balanced, and there is our balance equation with our states in there. Let's go ahead and write out a balance equation for the next example, and we can actually put states here. This is actually something where we know most of our states, and I'll show you how we can do that. So aluminum in the periodic table is in black font, so it's going to be solid. and we're going to react it with sulfuric acid using the naming system for acids, H2SO4. And because it's an acid, don't forget we put AQ. And then I told you that aluminum sulfate is a solution. Normally I wouldn't write that, and there's other ways to figure it out, but just for the sake of writing states here, you can do aluminum sulfate. So Al2SO4 3 AQ plus hydrogen. Hydrogen is one of those Hofbrinkels that exist as a gas at room temperature and its standard state, and that's because it's red on the periodic table. And so now we can balance. We have 3 sulfates here and only 1 sulfate here. So I'm going to put a 3 here, and that'll give me 6 H's and 3 sulfates. To get 6 H's here, I'll do 3 times 2. There's 6 H's. And then to get 2 aluminums here, I'll do 2 times 1. That's 2 aluminums. So we have 2 aluminums, 6 H's, 6 H's, and then 3 SO4s, 3 SO4s. And we put all our states and everything. So it's nice and balanced. We have our states. All our formulas are correct, and we're good to go. So now let's go and try the next one over here. This is a combustion reaction. So combustion of acetylene gas, C2H2, forms carbon dioxide gas and water vapor. So let's write a balanced equation for that. So acetylene gas, C2H2, and we know it's gas. And notice that this is a combustion reaction. So from that, you'd have to know that you're dealing with plus O2, because when you combust, you react with oxygen. And we get carbon dioxide gas produced, so CO2. Don't forget this is a gas state because it's a Hofbrinkel, and this is gas as well. And then also we're told that water is in the gas state like that. And so we can go ahead and try to balance this. We have our skeleton equation, but let's balance it to make a balanced equation so it follows the law of conservation of mass. We need 2 carbons. We have 2 H's already. We have 2 O's. We have 3 O's, sorry, so that's off. So I'll just balance my my carbons first. So let's see. So I need 2 here. When I do that, that gives me 2 carbons and then 4 O's, 2 H's, 1 O. I have 5 O's total. My H's are balanced, my O's are not. So I'm going to show you a trick here. So these can be a bit tricky to balance sometimes, but I have 5 O's total on the left side or the right side, because that's 2 times 2 here is 4, and then alone is 1. So that's 5 total. So that comes from here. And I want to get 5 on this side as well, without having to go back and forth and change everything. So I'm going to cheat. I'm going to use a fraction. What times 2 gives me 5? Well, 2.5, right? I can put 2.5 or 5 over 2. It's the same thing. So 5 over 2, or this is 2.5 times 2, gives me 5 oxygen atoms. The problem is when I balance, I can't have a coefficient that's a fraction like that. So I can get rid of that fraction by multiplying everything by, well, 2, because that's at the bottom there on the denominator, right? So multiply everything by 2, everything. So every coefficient by 2, and that should end up balancing the entire equation. So it's a cheat method that helps you to figure it out much faster than having to go back and forth, back and forth, back and forth. You can do that, but this method works out. So we'll get 2C2H2 gas plus, we multiply by 2, so 5O2 arrow 4, because we're multiplying every coefficient there, CO2 gas plus 2H2O gas. And we always go back and double check, right? So we have 2 times 2, 4 carbons. Okay. And then 4 times 1, 4 carbons. So carbons are good. And then for H's, 2 times 2, 4 H's. 2 times 2, 4 H's. So H's, hydrogens are good. Oxygens, 5 times 2, 10. Oxygen. 4 times 2, 8. 2 times 1, 2. 8 and 2, that's 10. So our oxygens are balanced, and that's our balanced equation for the combustion of acetylene gas. So we just did a variety of practice problems here for balancing these equations. All of these balancing problems over here have answers, different videos provided, a different perspective, so it gives you another way to learn the material. And then these are just some final tips and reminders. So usually when you're balancing, you can follow these tricks and tips, and they do help, but it's really practice that'll help. A few things to remember is you want to use the proper symbols. So you want to use the arrow not equals, for example. When you're balancing, make sure that you always use the simplest ratio If you do have fractions, you can get rid of the fractions. And remember that states are not written in the word equations, but they will sometimes be included if I give you a question where it's harder to figure it out. But you do know how to find out most states by looking at the periodic table of colors, the color coding of the font, by remembering your Hofbrinkel elements, and by also remembering that bases and acids are usually going to be aqueous in that case. And later on, you'll learn other tricks to figure out, if a certain ionic compound is aqueous or solid or whatever be the case. So that'll be coming later on. But now you have all the skills based on grade 10 chemistry to go into the next level of the grade 11 chemistry, which is taking a look at the different types of chemical reactions like double displacement, single displacement, synthesis, decomposition, combustion, but also predicting products. So not just identifying what the reactions are, but predicting what the products are going to be using certain patterns. Before you do that, you need to know how to label or how to write skeleton equations, balance the equations, write states out, and once you can do that, then you're good to go. Just remember, I think I forgot here to put the gas here, so don't forget that. That's important. As usual, there are worksheets that you can find in the learning goals for the unit. And please make sure that you go through the videos that are here to see the demonstrations and also different ways to solve some of the problems.